Here today we have a 2004 Subaru Forester. This one is the EJ20 engine, turbocharged, and the complaint with this is when you start it up in the morning and you drive it, when you hit the gas, it barely can move, it barely can get out of its own way. So you have to start it, let it warm up a bit, and as it's warming up, you can start driving it, but the power is very low and very sluggish. You cannot go uphill. But as it warms up, the power becomes more and more to the point where it gets full power when it's completely hot. So this client is out of town, out of the country actually, and I picked the car from his place. So when I started it yesterday, it had a distinctively dead misfire. I didn't carry any tools with me. I just went to pick the car, so I couldn't do any scanning, but it had a dead miss. What I did notice is when you floor the accelerator, this thing does almost nothing. The revs go up just slightly shy of 1,500 RPM, doesn't go beyond that, and you cannot drive. You can't even go up a bump on the road. But as it warmed up, two things started happening. One, the power came back slowly, but the second thing I noticed is the misfire started going away to a point that when I reached the shop, when this thing was completely hot, that misfire was completely gone. Now, he did tell me about the misfire, and he told me that is his main concern, but he told me the low power problem has been there since he had the car. So what I want to do today is just verify. Right now the car is cold completely. I've not started it this morning. I just want to go and start it and see whether we have a dead miss. If we do, I'm going to come here and get a strategy of identifying our misfire. Do we have loss of spark or loss of fuel? And then we're going to proceed. Okay, we're here. Turn on the car. Now, I've just noticed that right now. I didn't notice yesterday, but there is no check engine light on this dashboard. So let me put it off. Oh, this thing has a turbo timer. Now, let me give you guys a friendly piece of advice. Do not put turbo timers in your car. There will come a time when you need to shut down your car quickly. If you have this turbo timer, immediately you shut down, it's going to remain running. So if you're hearing noises that are metallic or anything and you want to shut down your car, you will not be able to do. Turbo timers are a bad idea. If the manufacturer did not put them in, don't think you're doing yourself a favor by putting them in. I'm going to see where it is and disable it because it's going to interfere with my findings. But for now, I want to put it on again. Yeah, this thing does not have a check engine light. Okay, let's start it. Now put it off. And yes, it does have a miss. Oh, it's running really bad. See what I meant about a turbo timer? I want this to go off quickly, but it can't. It's even a worse miss than yesterday. Go off, come on. Okay, let me first remove that turbo timer. I do not like it. And then let's go to the wiring diagram. Let me come up with a strategy of finding out what type of misfire I have. Alright, this is your turbo timer here, and we're just going to disconnect it. And look at that, aftermarket bullcrap wiring. This is what I see all the time. I have never seen anybody install aftermarket items properly and neatly. They always leave a rat's nest. Bad wiring. So disconnect that, and now we can turn on and off, and that's what I wanted. Okay, let me put this panel back and we continue with our diagnosis. We are in the wiring diagram. This is the engine control turbo model automatic transmission, and let us look for our coils and injectors. Now, interesting, look at this accelerator pedal position sensor and electronic throttle. Subaru started using drive-by-wire long before their counterparts in Europe and America. In 2004, Euro and American, they were still using a drive-by cable, but in Japan, it was drive-by wire. So here we have got our ignition coils, 4 coil packs, and we've got a master power feed coming through this bulkhead connector, B21, and on that green-red wire. So I'm going to put current clamp here on channel A for the coils, and that'll give me all these coils. I'll see them firing. And then right here we have our injectors, and the injectors come through the same bulkhead, B21. Interesting, here we have a power feed that feeds those injectors, but it also feeds this CPC solenoid. So what I'm going to do is look for the CPC solenoid. I'm going to disconnect it for now because I want to see only my injectors. So I'm going to put a current clamp on this yellow-green wire, pin number 1. That'll make me see all my injectors. So we're going to do that for now. And then, depending on what we see, we will do a further diagnosis. I just want to see, are we missing an injector or are we missing a coil? And maybe we should start by scanning codes, should we? Why not, since we're here? So let's scan codes, but I'm sure we're going to see either no codes or codes that will not help us. Misfires on these early models do not have counters, as far as I know, but let's scan it anyway. And finish scanning, and just as I expected, no trouble codes. So let's proceed with the picoscope. So where is our B21 connector? This is the connector view on the engine bay. And B21 is right here, and it is on the battery area. And let's see how it looks like. This is the connector face. Okay, so let's go to the engine bay and do our probes on B21. Here are our connections. Only 2 channels for now. Channel A is all injector currents from the injector power line. That's the red wire there. And then on the red and yellow wire there, channel B, all coils current, and that's the coil power line. And we have disconnected our CPC solenoid. Now the CPC is the canister purge control solenoid. It's just the purge valve solenoid. We don't need that for now. Let's disconnect it. It won't affect the engine running in any way. Let's go to the picoscope. We are ready for our first test. Let's start up the picoscope. We're running, and we're going to start the car, let it run for a very short time, put it off, and then we analyze our captures. There we go. And we just stop that. Let's pause that, and let's analyze this capture. Nice. Check this out. We are missing an injector. So this is one injector, second one, third one. Here we have an injector missing, and we have all coils firing. Again, very efficient use of your tools. We now know we have a missing injector. But as I said yesterday, this misfire doesn't remain persistent throughout the day. It only misfires when it's cold and then starts working again when it's hot. We know that we have a missing injector. So what is happening to that injector? Do we have a power supply problem? Do we have a control side problem? Do we have a wiring issue? What do we have with that injector? So what I want to do is first come here and measure all our injector currents. Let's see what we are pulling. 1.1 amps a piece. And I'm telling you, there's no way you can pull 1.1 amps and have a bad power supply. So I'm not worried about the power supply to these injectors. So what I want to do is this. Let me come here. We're going to leave this as connected. And I want to come here and identify which injector this is. So let's go to injector number 1, control. And we're going to remove this coil power supply line. So when we have injector number 1 in there, we're going to have an injector ID. So let's look for injector number 1 on our wiring diagram. Let's come here. Let's go to the injectors here. Fuel injector number 1. This time I'm interested in the control. And here we are on pin 9. And it's the pink wire on the body side and the white wire on the engine side. So let's look for that one, put a voltage probe on it and put it on channel 2 instead of the current and see what we have. So we're back here. We have removed the current clamp and I've put a voltage line on injector number 1 voltage control line. On channel A, we are still with all injector currents on the red power line for the injectors. Let's go to scope. All right, we're back here and I want to show you something before we proceed. I'm on a 100 volt scale for channel 2, and that is the injector channel. Injectors have got a high voltage kickback when they close, and it goes usually above 50 volts, and I want to see that kickback properly. That's why I'm on a 100 volt scale. So if you see low voltage here, we'll need to measure because my 20 volt is actually here, not up here where I normally put it. So we're going to start that, and let's put the key on. And first, let's measure our voltage to that injector. That's 11 volts. So that's good. So that's the voltage going into the injector and coming out, waiting for a command on the other side. And I'm on the other side of the power line. So that's excellent. Let us start the car. And let's stop it. Pause. Now, before we do anything, let's address this here. We're going to ignore this. This is nothing. It's meaningless to us. You've got to understand your tools and the limitations that they have. I'm using a current clamp, and this current clamp is lying right next to the heavy gauge wire that goes to the starter. That starter carries an insane amount of amps when the starter kicks. It's usually over 300 amps, the inrush, and it creates a big magnetic field around that wire, and that magnetic field is being picked up by my current clamp and it's causing interference. So we're going to ignore this section here, and we're going to focus here where the starter is not on and the voltage has stabilized. Now, wow, guys, look at this. What is happening to my voltage on my injector? Let's bring a measurement here. We should have a steady system voltage, which is 13 volts. That's where my 13 volt line is. When the injector is off and when the injector is commanded, we should go to 0. First, I have no magnetic kick on that injector. There's no inductive kick. But look at my voltage after that. Sometimes it goes quite low, like here. Let's measure. So coincidentally, I just happen to have probed the problematic injector. So our problematic injector is injector number 1. So here we have 8 volts. And then here I'm seeing a reflection of one of the other injectors. And I think I can see all of them. So that's the kick for one injector. That's the kick for another injector. Now we're going to ignore this. This simply tells me that inside the ECU, it's a chip that is controlling all 4 injectors. So we're getting feedback internally in that chip, and that's why I'm seeing this here. So that's not my issue, but I have control of that injector. I just do not have any current consumption. Now, if we have that, we either have a power supply problem to that injector, or we have a problem inside the injector. We don't have a control issue, because if you come here, we'll see that we actually are going all the way down to ground. See? And it's saying negative 137 millivolts. That's simply because my ground on the battery is not as good as my ground here. So it just tells me you're going all the way down to ground. I have never seen something like this before. Let me bring this line here. So we have an issue with the voltage to that injector, or that injector itself. Consistently, you can see we are dropping down to ground. So we are controlling the injector ground correctly. So the driver inside the ECU has no problem. Now, let me save this capture first before I continue. All right, so we know we have an issue with that injector. The strange thing is, like I said before, this car stops misfiring. So now we know why we're misfiring. We don't have any fuel to that cylinder. But this is not always the case. We do have complete control of that injector properly when this engine is hot. So here's what I want to do. Let's go back to the wiring diagram here. And what I want to do is remove my current clamp, because I know now we are dealing with a voltage issue. And I want to put all these injectors in the scope. Injector 1, 2, 3, and 4 on channel 1, 2, 3, and 4 respectively. Let's do that, and then let's run this engine. First, we're going to run it briefly and view all of them. And then we are going to run this engine till it gets hot. I want to see what starts to happen to injector number 1. But this is freaking awesome. So here we have probed the individual injectors, channel 1, 2, 3, and 4 on injector 1, 2, 3, and 4 respectively. Let's go see what they're doing. So here we are back, and I've put all the injectors in order, 1, 2, 3, 4, but the firing order of this engine is 1, 3, 2, 4. So I'll also want to observe whether we are firing them at the right time. Let's begin the scope. Again, we're going to run it for a short time. I want to see what we have. So first, key on, and I can see all the voltages are good except for channel A, which is slightly diminished, but we already know that. That's injector number 1. Let's start the car, and let us stop, and we're going to pause this. So let's analyze. The first thing I want to see, I already know one is messed up, but do we have others that are messed up? And doesn't appear to be. So injector 2 is good. Is it opening though? Yes, it is. We've got that pintle hump there. And this is what I was saying. That's a reflection from this one inside that chip. So I don't mind that. Injector number 3. Let's just look at the pintle hump. Yes, it has a nice pintle hump there. It's opening. And injector number 4. Yes, very nice pintle hump. So the only injector right now that's not opening is injector number 1, and it's messed up. Now let's look at our firing order. 1, 3, 2, 4. So we start from here. 1, then 3, then 2, then 4. So our firing order is correct. but we don't have injector number 1. So let me save this right now. So I've saved this file as all injector controls cold. Now I'm interested to see what happens when this engine heats up. But before that, let me just connect my CPC solenoid back. I do not want to introduce another variable. So let's control the CPC. So the CPC is connected back. Now let's start the car, let it warm up. I want to see what happens gradually to injector number 1. Now before we do anything here, we still have our misfire. I'm interested to see what power we have right at the injector itself. Because right now we are only 2 possibilities, actually 3 possibilities. Number 1, we have an interruption of power going to that injector. Number 2, we have a bad injector. Or number 3, we don't have a good control line to that injector or from that injector. Now this is a turbocharged engine. If you've worked on a turbocharged Subaru engine, this engine runs hot. Every piece of plastic here is going to break when you pull this intake out. And to reach that injector, as you can see, you can't even see it here, but to get to that injector, you need to pull the intake. Listen to this. See how hard these are? These are all plasticized. This intake is not coming out without us replacing all these hoses. I've told the owner of the vehicle, and he has told me not to touch the intake. He does not want to replace all these hoses right now. So let me try and see if I can sneak a probe to the injector, if I can get its connector head. If I can't, then we'll just go on a test drive and see what happens when our misfire goes away. But I need to make the right call. If I say we have a bad injector and we have a line to that injector that's bad, we're going to have an expensive repair on our hands for nothing. I need to check the power line of that injector and the ground line. So let me see if I can sneak a probe in there. There's my injector connector. I can barely get to it. To give you a perspective of where it is, that is your mass airflow. And I am looking right in there. And I've put my torch there. And that is the head of my injector connector. I have managed to probe that connector. It's one of the wires. I don't know if it's the power wire or the ground wire, but I've managed to probe it. Now let's go and start the scope and see what we have here. Let's start the scope. And we start this. Very nice, we're in the power wire. Stop the car, pause this, and guys, we are done. Pause the video and think through this. Do we have a bad connection to the injector, or do we have a bad injector? All right, let's see what we have. I come here and zoom in. Look at this. We are firing that injector. We are commanding it. But we do not have any injector opening. We have a bad injector. Now you may wonder, don't I need to probe the other side to know whether that control line is continuous, because we know the power line is continuous to the injector. First of all, let's measure the power that's coming into the injector. I can already see it's good, but for the rest of you, there we go. 14.1 volts. We have full system voltage to that injector. We do not have a power supply issue to the injector, but our injector is bad. Let's overlay these two. First, let me get out of here. And I want to overlay these two voltages together. So let me come here and zero it. And this is also zeroed. This is on the same zero plane. And at the same zero plane, look what we have. We have power coming into the injector and power coming out of the injector when the injector is not being controlled. Guys, there's no way you can have full power going to the injector, full power coming out of the injector if that control line has a problem. We have a bad injector. So how do you sell this job? The only way I touch this job is if he agrees to buy all new OEM hoses that we are going to remove, because these hoses will not survive. I'm not going to be stuck with a stressful job of trying to piece together hoses that break during a job. It's all or nothing for me. I've already sold the diagnosis. If he wishes my services to repair, we repair the whole thing properly. Every single hose up here that will be touched, that will be removed, will be replaced. That's my rule. I do not take anything less. Of course, you can go to somebody else, but my job is quality and my reputation is key. I'm not going to sacrifice it because I want to make a little bit of money. I will also recommend that he does the O-rings for the hard pipe that is down there. There are two O-rings that are notorious for leaking, and I can already see this one is beginning to leak over here, and his coolant level is actually low. This is totally empty, and it's because of that leak. Okay, the customer approved the repairs. We are on the bench and our intake is out. Now, in case you're wondering why you need to remove the intake, it's because this is very stiff. You've got one bolt that is up here, and then you've got two bolts that hold it here, and then you've got two bolts that hold the hard lines under the intake, which you cannot reach. So there's one here and there's one there. If you do not pull the intake, you're going to bend and possibly wreck this pipe assembly. I do not recommend you do that. That is why the intake needs to come out. I've already popped out the injector, and this is our guy. Now, why do we do what we do? There's no way of removing this without removing the intake. So what are you going to do? Are you going to guess? Well, to do that, you have to remove the intake, and then you will need to guess which injector is which. So what are you going to do? Put it back, put the intake back, test. That is why you need good diagnosis, so that you come here once and do it once. This is a big job. You do not want to pull this intake and get this thing wrong. So you have this injector here, which I am not going to pull out, because once I pull that out, that O-ring will be compromised. I do not want to touch that O-ring. That's your injector part number there, and that's how it's packed from Subaru. Now, they do not give you the ring that comes here. It's actually an insulator that comes at the base here, so you'll need to buy an original one. It does come with the O-ring, and it does come with a top insulator. I do not know why they don't give the bottom one. Okay, Now, while we're here, we can do a resistance check on this and confirm with the new one what the resistance is. This one was so bad that I'm sure it's going to show up on the resistance test. But trust me, I have seen some that are not bad enough to show up on a resistance test. Many times I have seen bad injectors which show good resistance. So this is an unreliable test. But for this one, since our voltages were so bad, I am very, very sure it's going to show up on the resistance test. So let's set up that. So first, let's take the resistance of a good injector. All right, so that's a good injector. We've got 12 ohms on a good injector. So let's pull that out and let's bring in the bad injector. And you can see that's really bad. 468 ohms. This is high resistance in this injector. So that's a good confirmation. But again, as I've said, 9 times out of 10, when I do resistance checks on injectors, they usually turn out good because they fail when hot. But again, this one was so bad. Now you may wonder, am I changing all injectors? No, I'm only changing one injector. And I'm putting the original Subaru injector. The reason is injectors do not fail a lot. I've seen cars 300, 400, 500,000 kilometers with original injectors. This is an unusual failure. That is why I have no problem just putting one injector. But I will tell you, I'll always replace every single hose that I took out, and I will replace it with the original Subaru hoses, and I have all of them here. Every o-ring and every hose that I touch, it's being replaced. Why? Because these hoses are very brittle. They break. I'll give you an example. Look at this one. This is the hose for the PCV that broke when I pulled it out. Broke in half. I'm not going to waste my time stressing over things like this. I always insist, if I'm to do the job, number one, the customer has to approve original parts. Number two, I must be allowed to buy the parts that I state need to be bought. This makes the job expensive, I know, and you may wonder, but there are some people who can't afford it. My answer is, unfortunately, I feel for you, but I'm not the person for you if you can't afford it. I do not have the time to redo work, and I do not like being stressed out by work. If a customer is unable to do the repair the way I tell them to do, I always just tell them, please go to somebody else, let them serve you better. But all my customers will tell you that when I do a repair, I do it once and that's forgotten. Rarely do I get comebacks. And if I do, it's usually because of parts. Sometimes you get new parts that are bad. I mean, what do? I warranty that. But most of the time, I would say 99% of the time, when I do a job once, it's done. And that's how I like to do it. So I'm not going to show the repair on this. My channel is not for repairs. My main goal for my channel is not to show repairs. My main goal of my channel is to show diagnosis. There are excellent channels on YouTube that show repairs, and I don't need to duplicate that. Okay, so we're going to put this back together, and then we're going to do the test after the injector is back in the car. Now, I just thought of something very interesting that I want to do. Remember, I told you that this car had an issue when I was driving it. When I reached my shop, this misfire went away and the power was normal. But when I took it from his house, it had very, very low power and had a bad misfire. The client also had a problem with my diagnosis, saying that there's no way it can be an injector because in his mind, he doesn't know how an injector would be bad cold and then good hot. Well, I want to show you. It all has to do with resistance. So I have taken the injector and I've put foil paper there because I want to protect my leads, and I will heat this injector up with my heat gun. Okay, so we are going to watch what happens to this resistance. From what happened when I drove and from his experience, I can tell you this will start dropping. So let's start the heat gun, start heating the injector up, and let's watch the resistance as we heat it. And look what's happening to the resistance. So this resistance is decreasing as this injector is getting hot. All right, so I think that proves the point. And if I continue hitting this injector more, I will bet you this will go down to the 20s. This was his experience and this was my experience. So if we put this back in the car right now, when it's this hot, what will happen is it will flow enough current to actually open that injector. That's what it's been doing. Contrary to what people know, we all know that when things get hot, the resistance increases. That's not always the case. When you have windings and the windings have a bad connection, maybe there's a point where it's broken and it's just slightly touching. When you heat it up, those windings close up and they make better connection, and that's what's happening here. So this bad injector will actually perform better when it gets hot. Just thought that was interesting. Let's do the repairs and then verify. All right, everything is back together, and now we are back here on our test points: injector current, coil current. Let's go to the scope and want to see what the new injector current is like. Okay, let's put the key on and let's start the car. Very nice. A bit of a rough running, but that's expected after a repair. But there's no misfire. Let's come here to our coils and injectors. And now we have got good current flow on all injectors, and those are all our coils. We're done with our repair, but remember, we do not have a check engine light here. This car has another issue because the engine is running a bit rough. I will not diagnose that for now. I'm paid only for the session to address the misfire, which I have addressed. But I'm just interested to see what other codes are there. So we're going to scan, and then I want to see what other lights are disabled. I think our ABS light has been disabled, and possibly our airbag. Let's see. No, airbag is there. We don't have the check engine light and the ABS. So those two are disabled. Let me do a full system scan, and then we are going to see what codes we have in those two. But I can guarantee you this was done for a reason. One quick thing, let's just do a rev up test. Very nice. Now we can rev up Remember last time we could not rev up like that. Beautiful. All right, let's scan this system. All right, just as I expected, we do have fault codes. Let's actually do a report. So in the engine control system, the OBD side, we have O2 heater circuit low, and then we have another one on the engine OEM side, and then brake control system. We've got power supply, voltage, rear right, rear left, ABS sensor signal, but these are old. Now this, I think it's because the battery was disconnected. But on our engine, we have our O2 sensor. Classic code, P0031, heater control circuit. I think this was done on the sale of the car. They disabled the check engine light because they did not want to repair this condition. Well, I'll let him know, but it is never a good idea to be going around with a disabled check engine light. That leaves you blind to stuff in your system and you don't know what's going on. Let's just quickly check live data. Since the check engine light is on and we have an O2 code, I don't expect this thing to go into closed loop, and yes, it's not going into closed loop. But let's just see everything else. Everything else looks good. Check if this VVT angle is going to actuate. And it doesn't. Wait a minute. Let me give it a brake torque. Okay, we have a problem with our VVTs, and I think I know what happened here. Let me do this again. So this one started moving. This one is not moving at all. Oh, now they're both moving. Okay. So I think I know what happened here. I think these were damaged when they were installing the timing belt. Most people hold onto the pulleys while cracking open the pulley bolts, and if you do that, you're going to bend the pin, and if you bend that pin, it tends to stick, and this one is sticking. Not very good. All right, we have nothing else that seems to be wrong here. I don't like the cooling efficiency of this car, but again, these are all things that are aside from my work. This car has other issues, and I do not do extra work unless I'm authorized to, so we're going to leave it at that. So this Subaru Forester is done and ready to go back to the owner. Bad injector, causing a misfire when cold, and then when it becomes hot, misfire goes away, and it's also causing low power. That's it. Another one for the books. Until next time.